Welcome back to my channel. I'm Brian Kafaki, and in today's video, I'm going to share with you the facts of life and using Python virtual environments. So let's jump in. Where are we going? We're going to start out by talking about what is a virtual environment, and that'll relate to the facts of life. Why do you need to use them? How to use them, and that's going to be a riveting demo. And then I'll show you how you can view and export package requirements. I'll do that in the demo, but I'll reinforce that with a little more information. Before I jump in, I want to relate to you something that happened to me when I was just a teenager. My father sat me down and said, Brian, you've been a Padawan so far, you're just a kid, but you got to give up that innocence now. You got to learn the facts of life. And the truth is, as a Python developer, you can't just pip install and conv install your libraries everywhere and just think everything's going to work. The reality, and I know you're old enough to handle this now, is that Python libraries can break your projects. I was shocked. I was stunned. I thought, no, you can just install them, right? It'll never cause a problem. But then I learned the facts of life. He was right. Just going around pip installing all your libraries wherever you want and not worrying about the impact on your projects is a recipe for disaster. So I hope your dad had that chat with you. If not, I'm going to have it with you now. So what is a virtual environment? When you install a Python package, all your projects are affected. What does that mean? Well, when you install a new package version, all of the projects that you have on your machine at that point will start using it. And there's a problem because each Python application is dependent on having specific versions of Python and its related libraries. Now, if you haven't used Python a long time, you're still kind of a newbie, that's okay. But I'm reaching a point in teaching you about Python that I need to get you beyond Padawan and into the Jedi Master. You're also going to need to understand this if you interview at all. Trust me, you got to know how to use virtual environments. So imagine you are writing some new apps and you install Python, you're ready to go. It's sitting there. In my case, it's under my Brian path, Anaconda 3. It's all good. I got all kinds of stuff on Anaconda, right? And I got my Python installation and I got my Python libraries, and Anaconda comes with a lot. And I say, hey, I'm going to write a web app and I'm going to use Django. So I create a folder and I set up all these things and I install typical pip install Django and requests and probably a bunch of other libraries. And bear in mind, Django itself installs a ton of dependent libraries, and then those libraries have other dependencies. They don't write things from scratch. In fact, nobody does in Python. Everything is a layering of a layering of a layering of libraries. So that's great. I now have my web app ready to go. I've got Django and I've got this app running and humming and it's great. And then a little later I say, I think I'll write a nice little Space Invaders game, and I create another project. This one, I have to install Flask. I install requests, which is also used by Django, and I install this great library called Pygame. No problem. I got that up and running. Great. Then a little later, I decide to do an Azure data application, and I need to install the Azure SDK, which is a large library with lots of dependencies on other Python libraries, and I'm installing Pandas SQL. Okay, so what's the problem? Well, here's the thing. When I installed my second project, I installed Flask, and Flask upgrades a library, could be many libraries, that's used by Django. I also installed a new version of the requests library, which is where you do like web requests or API requests over the internet. And for all I know, really, Pygame itself could have all kinds of dependencies of things it installed. The net result is I broke my web app because I installed libraries in one common place that all of my applications are sharing, and it broke my application. You might say, well, why would that happen? I mean, I've got the library. Well, there's two ways it could happen. One way is it downgraded a version of some of the libraries I was using, and I lost methods, functions, or classes that I was depending on. But probably even more likely is that in an upgrade, they deprecated or completely removed some functionality that had been in the package. That happens more than you might think if you haven't used Python a lot. But these libraries are living, breathing things, and they constantly change and dependencies change. So you have to be careful. This happens all the time. So now let's look at my Azure project. Well, here I installed the Azure library, which downgraded Pandas and Flask to earlier versions. It also installed a new version of Pandas SQL, which replaced the one that Django is using, and SQL Alchemy is replaced with a newer version. So now I broke my Space Invaders project. But I also added more problems for my web app because it also uses some of the libraries that I just clobbered with the Azure Data app. So you start to see the problem. These are just like really, we'll say simple, basic apps all sitting on my machine, and I broke them. Now, if they're not apps that I'm really using and not deploying to production, it may not seem like a big deal. Maybe these are demo things I'm doing, but it still could be a pain when I'm ready to go for a demo and show some class how awesome something is, and suddenly my project is failing and it's breaking left and right. I have to figure out how to fix it. Spoiler alert, it's not easy. Which packages, which dependencies? You might be getting a complaint on a library within a library within a library that has this really strange nuance of something that changed. And you're going to try to figure out, like, what do I need to reinstall to get things up and running on, say, my web app? But lo and behold, I'll end up breaking the other applications. So we have a double whammy of a problem, which is not breaking my applications as I install different packages, but we also raised another problem. How exactly am I documenting all these packages I'm installing? I mean, you go around, install this, install that, but at the end of the day, do you even know what you installed? Python is such a ubiquitous matrix of libraries that it's really difficult to even know what's being installed for your application. You may know, for instance, you install Pygame, but did you know Pygame consists of 300 other libraries under the covers? And they're all dependent on those versions. Each library has its own dependency. So I do want to emphasize that as well, because you might be thinking, oh, it's the request library or it's the Azure SDK. But when Pandas installs, it will install other packages, and it needs those specific versions for it to function. And guess what? Some of the packages it installs uses other packages, and it needs specific versions. So this dependency tree can be really large and really complex. You don't want to have to get into trying to manage it on your own. So let's reimagine a better world, a world in which these problems kind of magically disappear. We're going to reimagine a world with virtual environments. So now, as before, we have our Python installation, and we're going to write our web app. And when we do our package installs, we're going to do something a little different. We're going to use a virtual environment. And in that virtual environment, we're going to install Python, whatever version we need, the Django library, and requests. So we're going to have all the things we need installed. And you might say, well, what's this virtual environment? You can think of it like a container, and everything required for that application is installed in its own isolated virtual environment. The good news is it's actually pretty simple. It's just using a folder on your machine that installs all the libraries it needs. And then when you go to run it and you switch the context to your virtual environment, it just points you to that folder instead of the default Python libraries folder. So then we do our next project, right? Space Invaders. Again, we install a virtual environment, and then we do our package installations to that virtual environment. Again, isolated, separate from our other project. Then we do our Azure Data app. And again, we create a virtual environment and install everything we need into the virtual environment. And mind you, if you look at this, it also includes the Python version it needs. So these could have actually different Python versions. So this isolates projects from package changes. In other words, when we install different versions and things of our package libraries, not a problem because they're isolated and we won't break other projects. It also gives us a way to provide a list of the packages we need to run your project. Why would I need that, Brian? Well, imagine you want to say, hey, Joe, Harry, Mary, I want to give you a copy of my program to run. Well, they don't have all the different libraries needed to run your application. If you had a way to hand them a list and say, you need to install these packages before you can run my web app, then they're good to go. They know what they need to install. But it's not easy to remember. You install a lot of different things. So you don't want to have to keep track of this in your head. Virtual environments make this really easy. So some disclaimers before we get into more of this. I'm going to be showing you what I would say is the most common, the sort of standard way that documentation talks about creating virtual environments. There are other options. We're going to be using venv, which is the newer version. It's 3.3 and on, I think, that started using that. But you could be using Conda, for instance, also to do that. I'm not going to be talking about Conda here. I'm just talking about using venv. When using this method, only use pip to install your packages into the virtual environment. In other words, don't use Conda or anything else that would install packages. And the reason is I've seen a lot of things online that say, should you decide to just Conda install a library into your virtual environment, when you do things like pip freeze, which gives you a list of the packages that are in that environment, it skips over them. So you'd be missing some of your packages. So you want to just use venv for what we're showing here and pip install. So let's go into the riveting demo now. Now I'm working in Windows. I'm just at a DOS prompt. This is the easiest way to create a virtual environment. You could be using VS Code, Linux environment, whatever it is you're using, a script editor. Typically, you'll have a terminal window, right, where you can enter at a prompt. I'm going to do everything for now just at the terminal prompt to make this super easy to follow what I'm doing. So I'm going to create an application. And to hold all the files for that application, I'll create a new folder. So I'm going to say md yt demo. Then I'm going to change the directory to that, ut demo. Now I'm sitting here, I've got a place to create my virtual environment and all my stuff I need in my project. So the first thing I'm going to do is just create my virtual environment. So let's do that. Now this assumes I've already installed Python on my machine. So I'm not going to go through all that. You can look at the documentation online for installing Python. But assuming you have that, all I have to do now is say Python -m and venv, and then I give it the name of my virtual environment. -m, I had to look this up. When you say Python -m, it means take a library, in this case venv, and call it like a script, basically, execute it. So we're executing venv. I'm going to call it yt demo env, just so I can remember what it's called. That's all, just so I have a name for it. And the good news is, because I'm in this folder, it will create the virtual environment inside the same folder. So if we do a dir, you'll see there's a new environment folder created, our yt YouTube demo env. Great. What if I did tree just to see what's in there? And you can see it created a lot of folders. So this is not a trivial little thing it's doing a lot. Most of this we don't really have to worry about. The one thing I do want to show you though is this folder here, scripts. Scripts is where it has two important commands, activate and deactivate. So let's take a look at that. So you can see here we have activate.bat. If you're using PowerShell, activate.ps1. And then you have a deactivate command. And you can see also pip and all those other things in there. So we have our virtual environment. That's great. But we are not actually in the virtual environment. We need to activate the virtual environment before we can use it, before we should start doing any kind of pip installs. And also, once we're running our project and we're doing things, we always need to change the context into that virtual environment in order to run things, because that's the only place it's going to see all the libraries we need. So to activate the virtual environment, we need to run that activate.bat from where we are. So the easiest way to do that is just say yt demo env scripts, and then just say activate.bat. And you'll notice something. Suddenly you get this prefix to your regular prompt. That prefix in parentheses is the name of your virtual environment. So this is how you will know you're in a virtual environment. If you don't see that, you're not. If you see it, you are. When we're done using a virtual environment, we can deactivate it by using the deactivate command. Interestingly, we do not have to point to the path to use that. We're inside it. We can just say deactivate, enter, and you see that the prompt goes away. We're not in the virtual environment anymore. Now I want to show you a kind of a shortcut, if you're on Windows at least, of how you can bring this up and down without having to type in that long command. So what I typically do when I have long commands I need to enter on Windows is create a little batch file. So what I'm going to do here is say copy, con, and I'll call it set.env.bat, hit enter, and it just waits. What's it waiting for? It's waiting for me to type in something. I'm directly typing from the console. I'm going to save what I type in to set.env.bat. That's a little shortcut we learned back in the old days. So to execute the command, I'm just going to enter what I entered before to activate the virtual environment. So what I need to do here is say yt demo env scripts activate.bat. Hit enter. And now here's the trick. You want to do Control Z. That will end the file or close it, and then just hit enter. And now I have a file there. You can see it there. And all I need to do now to activate my environment whenever I come into this folder is just type in set env, and I'm in. Great. So now we have our virtual environment, got a little script file available to us we can use just to get into it anytime we want. And remember, to get out of the virtual environment, you type in deactivate. Well, now we're in it, and we need to install stuff. I mean, what good would this be if we weren't going to install anything? So very soon, I'd like to do a video to show you how to use this library called Streamlit. Streamlit is a really cool thing where you can create web applications easily. it's just a lot of fun, to be honest. So it's pretty cool. But I needed to introduce you to virtual environments before I get there because Streamlit installs a lot. And I didn't want you to clobber your machine with all this libraries from Streamlit without having a virtual environment. So now that we do have the virtual environment, let's jump in. I'm just going to say pip install Streamlit. Hit enter. All right, you can see a lot of gobbledygook on the screen, but there's a lot of stuff that was installed with Streamlit. I'm going to show you a couple of ways you can see what so far has been installed in your virtual environment. The first, which is meant to be used just to see what's there in a more sort of intuitive, readable format, is called pip list. And I want to scroll up here because look at all these libraries that were brought in as part of Streamlit. And a lot of these are common libraries that you would probably use in other applications. Now, one thing I didn't do also, it warned me you are using a certain version of pip. And pip is just the library manager. It lets you install packages. I'm not sure it really matters a huge amount which version of pip you're using, but they always complain if it's not up to the latest version. And it tells you what to do here if you need to upgrade pip. So you can always do that. I'm going to skip over that for now because I haven't had really trouble with using the version of pip I'm on. And generally, I don't think you will unless it's woefully out of date. So now that we've got that installed, the nice thing with Streamlit is it has a little demo we can do to see if it's actually working. So we launched this little demo app, which is just bringing us to the location of our Streamlit service. And it just shows us some links to documentation. But it's a nice little utility that shows that Streamlit is installed correctly. Now I'm going to do Control-C to break out of this. So now we're not running the app anymore. So let's see if we could run Streamlit without being in a virtual environment. Like, could it just work anyway? Let's try it. And let's try what we entered before. I'm just going to backpedal here. Streamlit hello. Can't find it. So we can see how in our virtual environment, Streamlit is there, but it's not available when we're outside of it. It's only in a little virtual environment. Very nifty. Let's go back in to our virtual environment. You can see by this, again, this is here telling us we are now actively in that environment. Because suppose I wanted to give somebody a list of packages they need to install in order to set up and run an application I've created. Now, this could be used by a friend. You're just giving them the program and all the libraries needed. But it's probably also going to be needed if you're professionally developing and you're working on your own machine and you're going crazy and installing stuff. You're going to want to have that. So when you move it to a development environment or even production at some point, you'll have the requirements file, which is what they actually call it, to be able to run your application. So we use this command, pip. Instead of list, though, this time we say freeze. And it is almost identical to what we had before, but here it just lists the packages and the required versions. And notice these are equal versions. So it's asking for specific versions. These are the things we had just installed as part of Streamlit. However, in order to get this to somebody, we need to do one little more thing here. I'm going to do pip freeze, but then we're going to use the redirect, which is this little caret in Windows, and we'll put it into a special file called requirements.txt. And now I'll show you that it really does have stuff in there. So I'm typing it, and you can see all that stuff. So all I have to do to allow someone else to install all the libraries needed for my application is hand them the requirements.txt file. Then they can just say pip install requirements.txt. And I'll show you that again later in the slide, exactly how that looks. What's nice is it's doing double duty. It's creating a virtual environment and allowing us to work in an isolated manner, but it's also tracking all the things we're installing so that we can install them somewhere else to create a copy of our environment. So one thing you may notice is that we only installed one package. We installed Streamlit. But in here, we've got a bazillion packages, which was all part of what Streamlit installed. But it also does show you Streamlit itself. Let's deactivate. So let's review the part about documenting and exporting package dependencies. You see on the left, and by the way, the link at the bottom is where I got the example code here. But you see on the left, pip list. We used that a couple of times. That will give you a sort of user-friendly format for listing what packages were installed into this virtual environment. But if you use pip freeze, that's going to use a slightly different format. And that's because this format where it says equal equal in the version is something you can directly execute. Now on this slide, you can see we're saying pip freeze, and we're directing it to the requirements.txt file, just as we did in my demo. To install this in another environment, you would copy the requirements.txt to that environment. Assuming we have pip and Python available in that environment, we just have to say pip install -r requirements.txt, and it will automatically go through all those different libraries and install them in the new machine. So the first link here is what I thought was a very useful blog explaining Python virtual environments using VENV, the different syntax, and overall it was pretty good, but be aware there are some pop-ups, and so you may find it annoying, or you may even get it blocked depending on your environment. The other docs you should not have any trouble with. These are standard Python virtual environment documentations from the Python documentation. So wrapping up, we talked about what is a virtual environment and the facts of life. I hope your dad had that conversation with you so you can avoid trouble. We talked about why you need to use them, and the idea here, of course, is you're building lots of applications eventually. You may be thinking, I'm still new at Python. I'm just trying to learn how to use things. I don't need to worry about that. That's a real dev type of thing. But I have to say, I started to hit problems very quickly, and I learned even when I was just first learning Python to start using virtual environments because things I created a month ago suddenly weren't working, and you get into trouble, and I don't know what I installed to get something running. So even just for like demos or learning projects, it really became useful to use the virtual environments, and you're going to need it in the real job. You want to be able to talk about that in an interview. You want to understand that's what the pros do. And we walked through a pretty extensive, I think, example of setting up and using a virtual environment. I like to use little batch files to make it easier, like I showed you how to set up something to activate the virtual environment. And I would suggest coming up with a standard naming convention for how you name your virtual environments. I tend to like either under the subfolder I'm in anyway, like demo one, I could just call it demo one, but I like to call it like demo one env. That way I know that particular subfolder is where all my virtual environment stuff is stored. Something like that I think is useful. Now bear in mind, I showed you doing it as a subfolder, but there are ways to create virtual environments where they all get cataloged into like a main folder too. So it could be put anywhere. It doesn't have to be in a subfolder. You can tell it to store that virtual environment folder wherever you want. And we talked quite a bit about viewing and exporting the package requirements, right? We use pip list and pip freeze. Pip freeze is the one which you would then direct it with a little piping into an output file, requirements.txt, which you could then use somewhere else to install and recreate your environment. Pip list is really just for a quick listing of what's in there. That's about it for this time. So thank you, share, subscribe, put comments in, please. And until next time, I'm pulling for all this together. Thanks.